Alright, this is the video for homework 2, question 2. The problem gets more complicated. It now involves multiple layers. Given probability of x1 to be 0 is 0.2 and x1 being 1 is 0.8, and for all k's from 1 to n, the probabilities for xk plus 1 to be 0 when x is a 0 is 0.6, and probabilities for xk plus 1 is 1 when xk is 0 is 0.4. Probabilities a probability for xk plus 1 to be 0 when xk is a 1 is 0.3, and probabilities for xk plus 1 is 1 when xk is 1 is 0.7. We have to find these results. To start with, we'll start from here. So basically, the probability for x2 to be 1 is equals these two equals 0. Let me see. So we have to make sure that x2 is a 1. So let k be 1. When x1 is 0, x2 has a 0.4 possibility to be 1. And when x1 is 1, x2 has a 0.7 possibility to be 1. And we will multiply these two with the probabilities of x1 itself. Here, these numbers are in reference. So that is basically 0.08 plus 0.56 and is add up to 0.64. The second problem, we have to find px3 equals 1. So basically we have to find px2 equals 0 first. That is 1 minus the previous result, that is 0.36. Then we can calculate in the similar manner, and here gives the result is 0.592. And then we have to find this one. The probability is for x1 to be 0 when x3 is 1. That is basically requires some calculation. So this is the conditional probability, and it equals this. The probabilities for x1 to be 0 and x3 to be 1 over the probability for x3 to be 1. This one is what we calculated in the previous question. Here, this number. And this can be calculated in this way. We have to focus on this term. This term here is calculated by this. These two expressions, and there's a exact number for this. So finally, we put these numbers back to this term, to this full term, and it is approximately 0.176. For the final problem, we have to find the limit when n goes to the infinity. What is the limit for xn to be 0? The probability for xn to be 0. First of all, we know that, oh yes, this here I have calculated an expression. That's a iteration expression, or I'm not quite sure what the term, or recurrence term for possibilities when for multiple x to be 0. So basically, the probability for xk plus 1 to be 0 is 0.3 times the probability for xk to be 0 and plus a 0.3. So we can use that expression here. So basically we have this expression here, and we know that x10 is 0.2, and we do some substitutions so we can get this term, and we rewrite, and we do some little tricks to find the general expression for an. That is this term, the general expression for this term, for the probability for xk to be 0. Then the calculation here is quite straightforward. Do some substitutions and calculations. Extract here. So basically bk plus 1 minus bk is 0.3 to the power of minus k. And we let that be a function. So we have b2 minus b1 is f1, b3 minus b2 is f2, and so on and so on, so on and so forth. And we add these equations together. So we cancel these terms, these two terms, and these two terms, all these middle terms in the middle. So we get a bk minus b1 is all these functions add up, function values add up. So here comes the expression. And then when we put ak back to bk, the position of bk, like this, so we have this one. And then we put the probability for xk back here in this expression, and then do the calculation. We swap the letters of n and k. We notice that this limitation is 0. This limit is 0. And so we only need to calculate this limit as I have written here. So basically that's something that you can calculate with some basic math. This is a 0. This is a 1. So it's basically 1 over 1 minus 0.3, and then minus a 1. That is 3 over 7.